Hey everyone, Dr. Calkins with week 7, chapter 17, the final installment with functional groups. We already talked about hydrocarbons. Let's give a brief review over those. So we have the alkane, which is a single bond. We have the alkene, which is a double bond. We have the alkyne, which is a triple bond. Different really only by the letter, A versus E versus Y. And then we have the unique arene, and that's the hexagon with alternating double bonds. So there's our 4 hydrocarbon families. Just remember, in this situation you have more letters, more bonds. So easy way to keep track of who's who is to keep in mind letters of the alphabet. The further you go in the alphabet, the more bonds you're going to attach to a carbon in that situation. One thing nice about a arene is it looks like a ring. So that's like the ring on your finger kind of idea. Sometimes they're actually written where all those bonds are connected because they have resonance around the ring and so forth. So those are easier ways to help memorize those. In most situations, these are what we would call R groups. R group just stands for random. And then this one specifically is a AR group, as it's the first 2 letters of its name, arene. So it's really only going to be important for one of our groups coming up, because you can really interchange any of these except for with 2 specific groups where they have to be very specific to be correct. So as we say functional groups, we just mean what happens when it's not just carbon and hydrogen, because these are hydrocarbons, these are non-polar. When do we have polar bonds like the ones in our body that we're going to see in our next chapter for biochemistry? So we really have 2 sets of 5. So the 2 sets of 5 that we're going to have is we're going to have 5 without a C double bond O. The C double bond O is called a carbonyl. So carbonyl. So you have 5 without and 5 with, and they're very similar, which makes them very difficult to deal with. A lot of the spellings are the same, that kind of idea. So one of the easiest ones is a organic halide. For this one, just remember a halide is a halogen, and those are group 17. So that's group 7 in Roman numerals. So the halogens we saw as early as week 2, so it shouldn't be too hard to recognize fluorine, chlorine, bromine, or iodine. If it's attached to carbon, we know it's an organic halide. Those are oftentimes represented as Rx, where X is any halogen, fluorine, chlorine, bromine, or iodine. Chlorine and fluorines, those are going to be polar because of electronegativities. Bromines and iodines, not so much. So there's 1. So we have 5, there's 14 total groups, so we're part of the way there. To recognize these, just recognize the halogen by name. So remember, it's going to be like a fluoro or a chloro or a bromo or iodo. We saw one of those examples on the other lecture. Another group, alcohol. Probably hear about those a lot. Alcohol is very easy to recognize because they end in OL. So things like cholesterol have alcohols, that kind of idea. Alcohols are ROH. And what's unique about an alcohol is there's a very similar sounding group called a phenol. Phenols also end in OL because they also have this very polar OH group that has hydrogen bonding capability, much like the alcohol. But a phenol is specifically the AR group, so it has the arene and then the OH, where this is just some kind of chain with an OH attached. So if you specifically have the ring structure, you're a phenol. If you don't, you're going to be an alcohol. So pay attention to those OHs because there's another group later that also has one. What's important about alcohol is very similar to being on the edge, this terminal kind of group. You can be internal. So what's unique about this is if you're an ether, you would be an ROR group. So an ether group, ROR, just means you're in the middle of a chain instead of on the edge of a chain. So uniquely, because of this circumstance, these are going to share the same formula of CnH2n plus 2 because they're saturated, but now they have an oxygen. So recognize those by being saturated with an oxygen. So they're much like an alkane, at least in Intro Chem they are, with an oxygen. Phenols we're not too worried about. Those are just going to be C6, H5, and then an OH. So it's just the same kind of ring structure we saw for an arene, but now with an oxygen. There's no longer 6 hydrogens on the ring. Now it's separated by that OH at the end. We're really not worried too much about this one up here. Doesn't really matter how many C's and H's you have, it's just you have a halogen. So don't worry too much about that one. The last group, because this is now 4, is the amine. And amines have nitrogen. There's no easy way to know that one. The only one that has kind of some clues, I'll go through that here in a minute. The problem with amines is they're very similar to some other groups called amides, both of which have nitrogen. So amines, typically the entire name like dopamine or methamphetamine, those are the ones that have nitrogen-based kind of groups. So a couple clues on these before we go ahead. So again, halogens, look for a halogen. So organic halides, halogens, group 7, 17. Alcohols have OH, so look sometimes for the name itself. Alcohol, the word, has an OH. That can be a giveaway to its formula. A fun way to learn an ether is you have an R on ether side. So that's a fun way to remember that one. Ether is like the word either, so maybe that can help learn that one. Phenol, there's no easy way for that one. Just remember it has the ring structure. And amine has nitrogen. So as we shift gears to the ones that have 5 with a carbonyl, so again that's C double bond O structure. Really what we need to do is kind of compare them at the same time to the ones above. So if we say amide, notice the spelling super similar, just D versus N. This is now our carbonyl, a nitrogen group, typically with hydrogens, although you can replace those with R groups or AR groups, doesn't matter. The only 2 groups that matter are these 2 for R versus AR. The rest are irrelevant. So in this case, the only difference is the double bond, but look at the D. D stands for double bond. That's an easy way to remember who's who. So D for double bond, and maybe we can keep those straight when it's important. As far as naming goes, or at least formulas go, this one CN H 2N plus 1 N, but really all that matters is it's got N, nobody else does. This one, same idea, CN H 2N plus 1, this is actually plus 3, but again, it doesn't really matter. And O. All that really matters is they have nitrogen and oxygen because of the carbonyl and because of the nitrogen group itself. So don't worry too much about the N's and H's on this one. Worry mostly about, do you have nitrogen or don't you? Do you have nitrogen or oxygen or don't you? The reason these numbers are plus 3s and plus 1s is again irrelevant for Intro Chem purposes. It's because nitrogen has an odd number of bonds. Not something that we're too worried about at this position. What we are worried about is the letter N versus the letter D, very different. The one that has the D has the double bond oxygen, the other one doesn't, so be careful with those. Another one that's very tricky is ester. The problem with an ester is it looks just like an ether, but it has a carbonyl. So ester sounds like grandma, and some students say that maybe this is grandma if you put a little emoji smiley face and this is her little shopping cart, who knows. Some people say that this looks like a car key and grandma can drive, ethers can't, so maybe that helps too. What's unique about the formula though is because it has a double bond just like these, now instead of CnH2n plus 2O, now we're just CnH2NO. Because now we have a double bond, these did not. Carboxylic acids, very similar. They're isomers, much like alcohols and ethers, so these are going to share the same formula. The difference is this group has carbon chains on both ends. Carboxylic acid doesn't. It has that terminal OH group, which makes it tough because so do alcohols and phenols, but they lack that C double bond O. But acids too have the same formula. The difference is acids are on the end, esters are in the middle. Alcohols are on the end, ethers are in the middle. Very similar kind of concept. edge versus middle, terminal versus an internal kind of group, sharing the same formulas. You'll see that in experiment, this organic experiment in your lab book. 2 more groups, and then functional groups are done. Esters, if you want to think about their name real quick, they end in O8, so methyl benzoate or citrate or stearate or monosodium glutamates, those kinds of ideas are esters, not T4,3 ions. Acids in an ic acid, so that's pretty easy. Amides in an amide, so that's pretty easy. So just recognize parts of their name, ester being the most specific one to this O8 kind of idea. Last 2 groups, so you have a R carbonyl H or an R carbonyl R. These happen to be isomers because they're the same, it's just edge versus middle one more time. We call these an aldehyde. Has an H in its name. Sometimes that's helpful. These end in al, so things like methanal or formaldehyde, same thing. Be careful, methanal is not an alcohol. Aldehyde's in an al, just like cinnamol, which is cinnamaldehyde. Alcohol's in an ol, so be careful with that difference. This is called a ketone. A lot of students memorize this one, just like the ester has a car key. This looks like a key to a car. So a lot of students say ketone, using the word key, even though it's misspelled, it helps memorize the name because the carbonyl itself looks like a car key in some weird sense. Formula here, CnH2n, because they have double bonds, but only one of them. Notice over here, I think I made a mistake because I was going so fast, but notice these have 2 oxygens, these only have 1. So 1 oxygen versus 2 versus 1. So notice these 2, a lot of students confuse them because here it's double plus 2, here it's just double. So pay attention to the number of H's. That's important for alkanes and alkenes as well. Because both of these have oxygens, that's where you're going to know the difference. Is it double or is it double plus 2? This one's a little bit easier because it has 2 oxygens, it's always going to be double, no matter what. Otherwise it's a mistake, like I made not putting on there in the first place. But definitely has 2 O's. 2 O's. 1 nitrogen, 1 oxygen, 1 nitrogen, 1 oxygen, only nitrogen. So there's lots of clues on who's who, and that's what we're after for functional groups. We need to know what they look like, we need to know what kind of generic formula they might have, and there's little clues on each one to help recognize functional groups as you look at drug molecules and start identifying them in some of our labs a little bit later on. So hopefully this helps at least give you some clues on what to look out for as you think about functional groups, because all of these are polar and all of these are part of our body in our upcoming chapter for biochemistry, and we'll see you